Now please welcome CTO Amazon.com, Dr. Werner Vogels.
Wow. Good morning, New York. Hey, come on. Amazing. Thank you all for coming out. It's outside very hot. It is nice and cold in here. So I hope that we can give you a really great day. The idea is always with these summits to make it a day of education. Not as much sort of the big sales talks or things like that. It is really intended for you to walk away today with better insight in what AWS can do for you. And one thing that is really important is to look next to you, because quite a few here in the room have been users of AWS for quite some time. And so there's lots that you can learn from each other. And I'm very, very happy always that in all the breakout sessions that we have, many of our customers are willing to sort of contribute, to tell their stories, to really tell the truth about using AWS. Yeah, and it's, there's well over 10,000 of you here today, with well over 80 technical sessions. And there's always, the expo has many of our partners there. In this case, 138. Please visit them and listen to what they have to tell you. We continue to grow. Millions of customers are active each month on our platform. And whether it's small businesses, young businesses, startups, although if I look at this list here, I mean, some of these are already some of the world's largest consumer brands. Whether that is Airbnb or Uber or Lyft or Coinbase, all of them have actually contributing to the new world of what I would call internet-scale companies. Yeah, and so here from New York, we have Peloton, of course, which is a very interesting company that built these beautiful race bikes that you can race against each other. And the live leaderboard of that in real time runs on AWS. Betterment, another company here from New York. It's a complete new online internet investment advice and management company that has services that are normally used by financial services and wealth managers, and they're offering it to you also running on AWS. And it's not just, of course, these young businesses. I mean, many enterprises already have a cloud-first strategy in place, meaning that anything new that's being built is built for the cloud. It's very hard these days to go talk to your CFO and ask for any money for hardware in your own data centers. And of course, many of our customers in the enterprise space already had significant on-premises infrastructure. Many of them are migrating en masse into the cloud. For example, General Electric continues to migrate thousands of core applications to AWS. They've begun this migration in 2014 and have migrated more than 4,000 applications onto AWS. Many of the GE businesses, whether it's power or GE aviation, healthcare, transportation, all of them are running their core applications on AWS. Another company here from New York, ISC Publishing, which you probably know about all the well-known brands that they have on the internet, Match.com, Tinder, Home Advisor, Dictionary.com. They've migrated well over 50 of these top internet properties all over to AWS. And it's not just the enterprises, of course, that are concerned about cost and agility. It's the public sector just as much. Thousands of government agencies are running on AWS. And here in New York, we have a great customer, the public library. They've migrated both their main property, the main website, as well as their digital collections website onto AWS. And well over 17 million users each year. 700,000 images are stored in the collections, and they're free available for everyone else to use. So it's a great, great service coming here from the public library here in New York. We couldn't do this without our partners, of course. Many of them have long-standing relationships, definitely in the enterprise space. And whether it's traditional players like Accenture and Capgemini or Cloud Native on CloudReach and Cloudpak. All of them are serving their customers. And these days, if you're an ISV, you have to make sure your software runs in the cloud. Quite a few of these ISVs have moved from let's say, a software install environment into software as a service. And cloud is really all powering that. Many of our customers asked for a path from their on-premise infrastructure into the cloud, making that easier, especially when it comes to sort of existing IT processes and policies and procedures. And so we announced in 2016 the partnership with VMware to build VMware Cloud on AWS, so that it makes it easier for customers to seamlessly migrate their applications from on-premise onto the cloud. And today it's available in Oregon, Virginia, London, and Frankfurt regions. And before the end of the year, it will also be available in Sydney and Tokyo. Important is for many of these customers the certifications that are available. And so VMware Cloud in AWS is now compliant with GDPR, HIPAA, SOC 1, 2, and 3, ISO 2001 and 17 and 18, such that customers really can continue to follow the same procedures that they had on-premise and then into the cloud. Now, if I think about our customers, I always think about builders. This is how we started to build AWS. It was important for us to not force you to develop in a particular way. The days, I think, of IT vendors or platform vendors that were coming to you and tell you, this is how you shall develop software, those days are long gone. And when we started to build AWS, we knew that applications were going to be built in a radically different way. And the important part of that was that we then would give you the tools to actually do exactly, build it in the way that you want to build. We're not telling you exactly, this is how you shall build your data lake. No, we'll give you the different options and make sure that you can have exactly those tools that match the way that you want to do development. And if I think about it, in the past, I think platform vendors or infrastructure vendors were really focusing on telling you how to build your house. Or actually, I think what you would get was a condo. And maybe you could move the walls around a little bit or paint the walls in a different color. But basically, the vendor would have told you how to build software. But if you really want to build your own house and build beautiful new houses, you should be able to just get the tools and build the house in the way that you want to build it. And so if I think about sort of how we were building in the past, I'm old enough to have built these sort of three-tier applications, web tier, application tier, database. But what happened was that in the early days, these may have just been serving web pages. But eventually, these applications became really complex, and more complexity got put both in the web server as well as in the application services, becoming massive monoliths that were very hard to scale. I've used Apache and Nginx as application routers instead of just web servers. Probably we've all done this. And when we started building AWS, we wanted to decompose these big monolithic building blocks into smaller ones, so that you could pick exactly those building blocks that you need. These days, maybe in the three-tier days, there was only a relational database. But now we've seen so many different types of applications with different needs around sort of how to use data storage, that you need different types of databases available for your customers. This is now how a modern architecture looks like. This iRobot are the guys that built the Roombas. And as you can see, there are no servers anymore in this picture. It's all Lambda triggered and connecting other services. And so if you look at sort of their complete architecture, there are no servers anymore. It's just really only picking the right building blocks that you need for exactly that application that you want to build. And of course, it's not just the backends and it's not just the infrastructure. It is also, we need to make sure that in a modern day, we can help you with doing really the development in the way that you want to do it. And it's, of course, there's whole pipelines in every development environment. And so got all the different pieces there. And not many cycles, of course, in there if you have to do repeated development. Definitely in a world of continuous integration and continuous deployment. It all starts, of course, with writing code. And you really need a great IDE for every platform. And I think with Cloud9, we've built an amazing IDE that can really help you do cloud-native development. It has support for local development with Lambda. Yeah? It's the only environment that actually helps you with doing that. So collaborative development is an important part of every development environment. And as such, the great thing about a cloud-based IDE is actually that you can sort of collaborate, even in places if you're not co-located together. Cloud9 is all based on the CodeStar set of tools. And with that, you can build your own pipelines. Or of course, Cloud9 sits on top of this and directly integrates with that CodeStar pipeline. It's not just important to think about sort of how you do develop code, but also how to do production. Yeah, I mean, after all, you need to run your software somewhere. And so, again, a whole series and set of tools available for you so that you can do exactly the way that you want to do production. I want to call out one, that is X-Ray. If you haven't been looking at X-Ray, please take a look at it. It gives you a deep insight into your distributed applications. Yeah, where in the past, maybe you're building big monoliths and it might be easier to debug those. In a modern world, most applications are built out of different distributed systems components. And so it's sometimes harder to debug and harder to track where performance problems are coming from. And so X-Ray, if you enabled it, can give you deep insight in exactly how errors and control flow go through your different pieces of your application. With all of this, by now, we're delivering more than 125 different services to our customers. Last year, we added well over 1,400 main features and services to our world. And whether that is the days of that, it was just infrastructure, compute storage, databases are long gone. It's really a very complex set of services that you can use to pick exactly those tools that you need for your mobile development, for your IoT development, for your analytics, for your machine learning, all of these different components. And as you can see, when you compare this to other players in the market, AWS is far ahead of everything. Of course, we had a head start in this, but important in the cloud world, I think, is that there is no compression algorithm for experience. It is really building exactly those tools that our customers need. And so in a moment, Dr. Matt Wood will come on stage and talk to you about sort of all the machine learning capabilities that we've built in the past years. But first, I get to introduce one of the most exciting customers that I've met in a long time. Yeah, I'd like to introduce you to Chris Dill. He's the director of platforms for Epic Games, the creator of Fortnight, one of the most popular games in the world at the moment, and absolutely a global phenomenon. Chris.
Nice shirt. Thank you. Hi, good morning, everyone. Thank you, Werner. Good morning, everyone. Thank you for... I'm Chris from Epic Games. I'm here to talk to you a little about Epic, our products, and how we use AWS to manage our infrastructure. I believe a lot of you know Epic from our very popular game, Fortnite. And for those of you who don't know Fortnite yet, you now know it from a Werner shirt. So thank you, Werner, for that. Very appreciate it. Even though we're called Epic Games, we definitely do a lot more than just games at Epic, right? Over the years, you can see a number of games. You've probably played some of them, from Gears of War, Fortnite, certainly everyone knows, and so on. So Epic's been around since about 1991. Today we have over 800 employees with 50 major studios and locations around the globe. In addition, we're also the developers of the Unreal Engine, which is a suite of creation tools enabling some really amazing experiences. So Unreal Engine's been the core of Epic's business for many years now. We've got millions of developers around the world. I think we just announced about a number around 6 million people who actually use Unreal to build any kind of high-fidelity interactive experiences on a variety of platforms: PC, console, mixed reality, virtual reality platforms, et cetera. And it's freely available at unrealengine.com, so you can download it today. In addition to Unreal, in addition to games, Unreal is now used by a lot of enterprise applications as well. So everything from automotive, movies and film, broadcast television, and a lot more. So let me just show you a little bit of just how cool it is. So here's an example of a real-time digital human showing the power of Unreal. In this case, you've got Andy Serkis. Basically, we're transferring the actor's facial expressions onto a real-time digital character. So really, really cool stuff. This is all powered by the engine, all done by the real-time graphics that the engine does in real time. So really amazing stuff. And if you guys want to learn more, please just check out our blog on unrealengine.com. We're always putting out new demos, new press releases, et cetera, showing off some of the powers of this. So in addition to the incredible experiences we're enabling with Fortnite, with the engine, let's talk a little bit about Fortnite. So a lot of you know Fortnite. It's become a pop culture phenomenon across the world, and we're very proud of its success. If you haven't played it yet, Fortnite's a free-to-play game, 100-player, last-man-standing game. Imagine after skydiving out of the battle bus, right? Shooting out with other players, building defensive structures, on your way to winning the game. What we like to call a victory royale. So Fortnite's a very popular game. We have announced over 125 million players worldwide and millions of concurrent players all playing the game at the same time, even right now as we speak. So now that we've talked a little bit about the game, let's talk a little bit about actually what's powering it. So Epic began its transition from a developer of games with Gears of War to a full online publisher using a games-as-a-service model sometime around 2014. And of course, we needed a reliable cloud provider that would provide all the basics we needed so that we could really focus on the innovation of our products and our platform. You can see by all the plethora of AWS services, we're basically all in on AWS to operate our services for Fortnite and our platform. So AWS has really enabled a number of things for us. So Fortnite has grown more than 100 times in the last 9 months alone. We have an almost 10 times difference in game server workloads between high peak and low peak in any particular region. So a lot of allocation, deallocation of servers all the time. We run our servers in more than a dozen different locations. I think the last count actually was 24 availability zones around the world, basically to provide the best customer experience to our players. So we've run some recent events in Fortnite to really test the boundaries of scale. So as part of the storytelling of Fortnite, we did a one-time global event that lasted literally only several minutes, and we launched a giant rocket ship in the game. We invited all 125 million of our players, right, into the game, right, all to participate at the same time. Crazy, huh? So needless to say, we achieved a level of scale that we had never before seen in Fortnite, possibly even for any other game in the world. And if you did get iced on that day with any C-series EC2 instances, that was probably us. Like, we really stretched the capacity to the limits, for sure. So let's take a little bit closer look on how we actually accomplished all this. So Fortnite run primarily on AWS. As I mentioned, we got worldwide game server fleet across multiple AWS availability zones. We have a platform of various backend service databases and websites that support the operations and publishing of the game. We have a large analytics ingestion pipeline that supporting all of Epic products, including Fortnite and Unreal. So we have dozens of microservices using a variety of technologies from Java, Akka, and even Go. So don't have time to talk about all of it, but let's actually do a deeper dive on our analytics pipeline. So to show a little bit about the scale that we're dealing with right now, we have an enormous amount of telemetry coming in from our users. So our game clients send data constantly all the time, 92 million events per minute, leading to 2 petabytes a month of data. So really just staggering numbers of data coming in that we'll use for various reasons. We'll talk a little bit about how this all works. So the entire analytics platform is running on the AWS infrastructure. We've got telemetry coming in from to a Kinesis stream. We have about 5,000 shards of Kinesis running to ingest all that data. We have a combination of a real-time pipeline and a batch pipeline. The real-time pipeline is largely driven off of Spark, and then DynamoDB for temporary storage, which feeds a number of different sources, Grafana, scoreboards, some limited-time ad hoc SQL type stuff that we do. And then on the batch pipeline side, everything is stored in S3. So S3 is our data warehouse. It's where we store all of our data for our data lake and our data warehouse, everything incoming. And then we do a lot of batch AWS EMR, batch processing on that to actually turn the data and summarize it in tables. And then we put high over S3 to provide that to a number of different sources, largely Tableau for business intelligence and reporting, and then also ad hoc SQL for a lot of our analysts to use for doing deeper gameplay telemetry. So let's talk a little about how we use this data. So one of our primary uses is around service health. So we use this for monitoring the quality of the service that we're providing in the games from the point of view of the client. So the clients are really a great place to actually understand exactly what the user's experiencing, what kind of problems they're running into, et cetera, et cetera. So we use this as an early detection system for a lot of issues, a lot of problems. Some things that you can't even detect from backend services, such as ISP issues or other things that go on. We also use it to run live tournaments. So we actually recently did like a pro-am tournament where tournament managers can set up custom scores and custom rules that basically drive real-time scoreboards that we can actually give away prizes of anything from money to swag and stuff like that at the end to the participants. We drive a lot of basic KPIs that we talked about, all the business intelligence things, ARPU, and, monthly active users, et cetera, all the basic stuff we need to run the business. And then we do a lot of stuff around game analysis, basically looking at the overall design of the game and basically saying, hey, are there any improvements we need to make to the balance or other things? So looking ahead a little bit, we've got a lot of work we want to do on the globalization of our services. Right now, that platform we talked about, while the game servers themselves are distributed, a lot of the services are centralized to only a single availability zone, and we really want to push that out just for the sake of global resiliency. So when we have a problem, it doesn't affect so many users. We're looking at, with all the growth, we really want to look at better ways of managing all these microservices. So we're looking at things like EKS and Kubernetes to help manage some of this stuff, and things around Amazon Guard Duty automation. We have a lot of we have a lot of threats coming in all the time, and we just really want to make sure we're on top of that stuff. And then looking at things like Neptune as well to help build things like social graph and anti-fraud type tools. So we've been busy. We just launched season 5 of Fortnite Battle Royale on July 20th. So let's watch the trailer. Cool. Thank you all very much. Enjoy the rest of the summit. And I'll see you all on the battle bus.
Ladies and gentlemen, will you now please welcome GM Artificial Intelligence Amazon Web Services, Dr. Matt Wood.
Good morning. Thank you, Chris, and thank you, Werner, and thank you all very much for joining us this morning. As many of you are aware, machine learning is experiencing something of a renaissance in the cloud. And while some of the methods that we use to drive intelligent systems haven't changed really over the past 60 years, most of the constraints which have held back their applications have completely melted away in the cloud. We can store as much data as we want, and we can pull down as much compute as we need to train models using that data. Then we can take those models and put them into production in enormous scale. And on AWS, we have tens of thousands of active developers running machine learning on AWS today. And that's a growth of 250% year over year. Machine learning has truly arrived for every developer. So much so that through the removal of these constraints, today, 8 out of 10 workloads run on AWS. And if you take a look at the types of customers, virtually every size of organization in virtually every industry is starting to use machine learning in development and into production. I wanted to give you just a few examples. One of my favorites is GE Healthcare. GE Healthcare are using machine learning to drive better insights from medical images. They're able to look inside medical images, chest x-rays, head CTs, and understand what's going on at or in advance of expert physician levels. This means that they can detect cancer and problems earlier and actually treat them far before they become symptomatic for the patient. At the other end of the spectrum, in terms of sports analytics, the NFL are running all of their next-gen stats on top of AWS. They're able to look inside both the video and the telemetry from players and do everything from route prediction to understanding how the different plays interact. Tinder. Every single swipe and every single connection on Tinder is driven under the hood by a machine learning model which is running on AWS. Hundreds of millions of customers, tens of millions of connections, all driven through machine learning. And at the other end of the spectrum, Moody's, in the regulated financial services industry. Anybody that works in this industry, very common in New York, knows that financial services is a goldmine of printed and scanned documents. Tens of millions of reports that contain financial data, portfolio reviews, and so on. So what Moody's did, working with the AWS machine learning labs, was to be able to look inside those reports and be able to extract automatically, with close to 100% accuracy, the data inside those reports so you can get better analysis of the data that's inside them. I'm also very proud to announce some new customers today that we haven't talked about yet. The first is Celgene, large biotechnology company. Celgene are using SageMaker on AWS in order to allow their scientists to be able to predict drug toxicity. This means that way before a drug or a medication gets anywhere near a clinical trial, their scientists are able to try and predict the toxicity levels. And this is very common where Celgene specialize in cancer medication. That means they can dramatically reduce the toxicity of cancer medication and dramatically accelerate the path to market for new medications. Formula One. Formula One have chosen AWS to run their machine learning for all of their races. Every single Formula One car contains about 120 different sensors. And in the course of a race, they're collecting about 1,500 of data points every single second. It's about 3 gigabytes of data just from a single car in a single race. But Formula One are able to look across every car in every race for 65 years in order to be able to do predictions on performance. They're able to do race outcome predictions and develop better strategies, which they can then show to Formula One fans on the broadcast. Large pharmaceutical company, Bristol Myers Squibb. Bristol Myers Squibb's data scientists are using SageMaker to dramatically accelerate the path of drug discovery. And this allows them to bring innovative new medicines to market a lot more quickly. And finally, Snapchat. Snap are able to use deep learning to be able to look inside the images that are being shared by their hundreds of millions of customers. They're able to look inside and identify the relationship of objects, people, and places inside those photos. They train routinely on over 100 terabytes of data and then serve up those models through SageMaker to hundreds of millions of customers on the Snapchat platform. So our mission at AWS with the machine learning is very similar to the mission that we've had at AWS since the very beginning. Our original mission was to be able to take technology that was traditionally only within reach of a very small number of well-funded organizations and put it in the hands of every single developer. And we've done that reasonably successfully with compute and with storage and databases and analytics and data warehouses, and we're taking the exact same approach with machine learning. Now, machine learning, it's still relatively early, and it's still a relatively nascent technology. And so we've had to build an entirely new stack of applications, services, and frameworks in order to be able to allow any developer and data scientist to start using machine learning. We think of this in 3 real tiers. At the bottom tier, this is the most technically advanced. This is really the domain of research scientists and data scientists. who are using low-level machine learning frameworks, usually open source, called things like TensorFlow and Apache MXNet, PyTorch, Caffe2, Chainer, and so on. And these frameworks are the programming languages for machine learning. They allow you to specify your algorithm, to design your neural networks, and then go and train them at very, very large scale across large amounts of data. And they each have their own sweet spot. TensorFlow has an amazing community and is well represented on mobile. MXNet does really, really well when you want to scale, particularly across multiple instances. PyTorch is great for prototyping. Caffe2 is amazing for computer vision. And what we found is that developers want to use all of these together. It's just too early in machine learning to want to specify a single framework and stick with it. Today, 2/3 of developers are using multiple engines in order to be able to get their real work done. And our approach, just as Werner was saying before, is to not be paternalistic. We want to support all of these frameworks as first-class citizens across the platform. This includes novel, cutting-edge technologies such as Horovod, which brings large-scale, fast, distributed training to TensorFlow, which we added to AWS a couple weeks back. At the next level up, this is really the realm of developers and data scientists who have data sat in S3 and want to be able to train custom models using that data. And here we see customers using SageMaker to build, train, and deploy custom models using that data up in the cloud, and also to be able to deploy it down at the edge and prototype with devices such as Deep Lens. So let's take a deeper dive into Amazon SageMaker. There's really just 3 things you need to be able to do. The first is you want to be able to train your model using custom data. And to do this, today, you can bring up your own algorithms. You can just specify a container and give it to SageMaker, and SageMaker will handle all the training and the distribution for the training job. You can, with just 20 lines of Python, start running your own TensorFlow or MXNet algorithm, very easy. Or you can train with the built-in SageMaker algorithms. Now, these built-in algorithms are one of the miracles at the heart of SageMaker, in my opinion. They are designed for what we kind of half-jokingly call infinite scale. And there's a remarkably broad set of capabilities inside SageMaker which are available to you right off the bat. Things like cutting-edge, deep learning-driven object detection for computer vision, or text classification, which is accelerated with GPUs. We have multi-class classifiers built right in there, and we even brought the forecasting algorithm, what we use inside Amazon.com for all our retail forecasting, and put that right inside SageMaker as well. It can handle billions of time series data in order to be able to provide a very accurate, deep learning-driven forecast going forwards. And every single one of these built-in algorithms is designed to be 10 times better, 10 times faster, 10 times cheaper, 10 times more efficient. And at the core of that is the streaming data approach that we use. So a common occurrence in machine learning when you get started is you want to be able to take your data and you want to be able to put it near the compute so you can run your training on it very, very quickly. The trouble with that is you have to wait for the data, which can be, just like we heard with Snap, hundreds of terabytes, to copy over to your compute infrastructure. And that just is slow. Also, it limits the amount of memory, it limits the amount of data that you can use based on the algorithm. So instead, we take data and we stream it direct from S3. We don't do any copies. We stream it direct from S3 with a high throughput connection, and we do a single pass train over the data. That means we just need to iterate over it once. And because we're streaming it from S3, we can checkpoint our models at any point in time. And that allows us, when we want to retrain or modify our model, we just add more data to it. We don't have to start from scratch. And all of this is available at the end of an API. If you can call a Lambda function, then you can do all of this inside SageMaker literally this afternoon. But one of the things we hear from customers is, how can we make our own algorithms, algorithms that our data scientists and developers are building for our own business, as fast as the ones that are inside SageMaker? And the truth is, today, this is kind of cumbersome. You can do it, but it's very, very difficult to get right. It's very hard to get the performance, and it involves getting really into the weeds on a whole bunch of low-level, low-lying C++ code. Nobody's got time for that. And so today, we're introducing a new feature, which we call Amazon SageMaker Streaming Algorithms. Streaming algorithms allow you to accelerate your own algorithms by taking the same approach we use for the SageMaker algorithms and stream large volumes of training data from Amazon S3 through your model. This is great because it allows you to stream it into your own algorithm. It dramatically reduces by up to 90% the amount of time it takes for your training to start, because you don't have to do that copy step up front. It also means you can just drive more data onto your GPUs and your CPUs to drive your training. That means they operate more efficiently, and it can cut down the time that it takes to run your training models. And because on AWS everything is metered and only pay as you go, every second counts. So if you can reduce the training time, you can dramatically reduce the training costs. So we're bringing this today to TensorFlow, and we'll be applying it to additional frameworks coming soon. So once you have trained your model, another step in machine learning is the optimization step. And again, just from the end of an API, you can run high-powered, machine learning-driven parameter optimization, which continually searches for the best possible model for your training data. And once you've optimized, most customers want to be able to host their model. They want to be able to put it into production. And so we provide A/B testing for those algorithms so you can deploy them safely. And we provide robust, elastic hosting for those models right inside SageMaker. Now, the elastic hosting is, as you would expect, very easy to integrate. We take your model, we deploy it onto a fully managed infrastructure, and we give you an easy-to-integrate API endpoint. Then you can drive low-latency, real-time predictions using that model. Under the hood, we'll auto-scale to make sure that we're providing the right level of capacity. And we'll do that across multiple AZs to provide fault tolerance to the model. So this is perfect for real-time, low-latency predictions. But there are some situations where customers want to be able to process a whole bunch of data just all at once up front in batch. Or where they have very, very large files, such as those medical imaging files that I was talking about before, or 5K video, where they want to be able to process a big file all at once. So today, while we're well set up for real-time, customers want to be able to have more flexibility to train batch and large files. And so today, we're introducing a new feature of SageMaker, which we call Batch Transform. SageMaker Batch Transform provides fully managed, high-throughput batch transform jobs with a simple API call. So this means that you can process data dumps in a batch. If you have a new set of billing inventory, if you have a whole bunch of product sales, you can just take that at the end of the day and just throw it against your model and start doing your predictions. You can also process large files, 5 gigabytes and up, much more easily without having to chunk them into pieces. And what a lot of customers are doing are using this approach to test their models. So once they've trained a model, they have a test set which is well understood, and they just run through that as a sanity check to make sure it works before they start rolling it into production through A/B test. And that works if you want to run it in the cloud, or if you're deploying those models, say, to an MRI machine which sits in a hospital to run at the edge. So the joy here is that you can use the exact same models that you're training in SageMaker today for real-time predictions and run the exact same models for batch predictions. And you can take all of the pre-processing and post-processing steps and bring those into your batch processing workloads as well. And again, this is all fully managed. If you've ever run a training job in SageMaker, this is virtually the same API. And so through all these capabilities, the training, the optimization, the hosting, we see a dramatic decrease in time that it takes customers to take their machine learning models, train them up, and put them into production. Intuit are running close to real-time fraud analytics driven by machine learning on their platform routinely. And they were able to reduce their deployment time down by 90% using SageMaker. It used to take them 6 months to build a model and get the first version into production. Now they can do it routinely in less than a week. So that's the machine learning platforms. At the next level up, we have a set of AI services. These are really designed for application developers who don't want to get into the weeds of how machine learning operates. They don't want to have to become deep learning experts. They don't want to have to go and label a whole bunch of data. They just want to get stuff done. And you can see right off the bat, you get this broad set of capabilities available to you. For computer vision, using services such as Amazon Recognition, which provides image analysis and facial detection, Recognition Video, which provides video analysis, pathing, face identification, speech using Poly, which is a text-to-speech service, the same service that we use to generate the voice of Alexa, or Transcribe, which does it the other way around. It takes speech and turns it into text. Or in terms of languages, Translate, which takes text in one language and translates it into another. Or Comprehend, which looks inside the document and all of the text, takes all of the context, and then allows you to drive better insights and understanding of what that natural language text looks like. from completely unstructured information, all the way through to Amazon Lex, which is a natural language understanding and speech recognition system that a lot of customers are using to build chatbots or use in contact centers as IVR systems. And Lex is the exact same beating heart that we use to run Alexa for the Echo and other Alexa-enabled devices. So whilst all of these services are designed to work independently and have a broad set of capabilities themselves, the real magic comes as customers start to pull them together. And they can be joined together for some common use cases. And so I just wanted to close out this section of the keynote with just a few examples of the use cases that we're seeing and some of the trends. So the first is really, as I was saying, contact centers. A lot of you here, I'm sure, have some involvement in the IT associated or even the staffing and the implementation of contact centers, large contact centers. And what we're seeing is that artificial intelligence can play a key role in driving a better customer experience and more efficiency inside contact centers. So here's a quick example of very high-level architecture. So if we flow kind of left to right, on the left-hand side, we have Amazon Connect, which is our call center in the cloud. We also integrate with any other popular call center system. And you can put Amazon Lex with all of its speech and natural language understanding and understanding of the tasks that customers want to get done, and you can put that in front of your human agents. And we see some customers that are able to handle 40% of their call volume just with fully automated Lex chatbots. That means that your agents are able to spend more time and that there's less queue contention to get to actually speak to somebody for more complex challenges. Once a customer calls in and gets to speak to a human, typically you want to be able to transcribe that conversation. You want to be able to take what was said and transcribe it from speech into text. And then you can start to run analytics against that text. Using Comprehend, you can look inside it, and for every day or for every week, completely automatically, Comprehend will look inside that and start to identify the key topics and trends that are being talked about in your contact center. And you can run more analytics downstream. But with contact centers, of course, transcription, if we're to zoom in on that section, is a little bit more complex than just dictation, because there's multiple people speaking. And in most contact centers, the way that that is recorded is in multi-channel audio. And so today, to make this a little bit easier for organizations to drive better analytics and get better insight using artificial intelligence in their contact centers, we're introducing a new feature for Transcribe, which makes it much more compatible with contact centers. And we call it channel synthesis. Channel synthesis for Transcribe brings fully automated multi-channel audio transcriptions to the cloud. And so we go to something that looks a lot more like this. Audio comes in at one end. This is just the recording with the customer and the agent on multiple channels. And then automatically we detect that and we split it into the individual channels. We transcribe them separately. And this is where the real magic happens. We use the timestamps from all of that transcription to be able to fuse and synthesize a single transcript, where we're able to identify both individual speakers, but keep the conversation fluid. And from there, you can start sending that transcript to make sure that customers, to understand the sentiment of what's being said, or even to check for compliance, where agents are saying the right phrases going forwards. So channel synthesis is available today. And another joy here is you only pay for this once. So you don't pay for both transcriptions, you just pay for one. Another very common trend is customers using artificial intelligence to drive better voice of customer analytics. So here, you're taking all of the inputs from your customers. This could be social media, looking at feeds from Twitter, or all the emails from your support channels, support forums, and so on and so forth. Now, increasingly, because of the breadth of the cloud, more and more companies are able to operate on a global scale. And you'll have support and inputs coming from your customers in multiple different languages. So here, we can just use Translate to translate all of that into English, and then pipe that English language into Comprehend. From there, Comprehend will look inside the text, and it'll start to identify the sentiment, it'll start to identify the entities, the people, places, things, products, and the key phrases which are being used by your customers. From there, you can drop all of that into DynamoDB or Amazon S3 or Redshift and start running analytics using QuickSight or ad hoc queries using Amazon Athena. So what can we do here to improve on this very common voice of the customer use case? Well, the first thing that we can do is we can get upstream, and we want to be able to broaden support for more languages in Amazon Translate. So today, I'm very proud to announce that we're adding 12 new language pairs to Amazon Translate. Japanese, Russian, Italian, traditional Chinese, Turkish, and Czech. And we'll have 12 more language pairs coming by the end of this year. So that's Amazon Translate, dramatically broadening the reach and the input that you can take from your customers by broadening the language support. Next, we want to be able to look inside the language which is being used with more fine-grained details. We hear from customers all the time that they really, really like the ability to be able to identify products and to identify people and places and themes, but they'd like much more fine-grained control over exactly what was inside the text. And so today we're allowing customers to start to dive in, not just at the sentence or the document level, but look at actual individual words and classify those words with a new feature which we're announcing called syntax identification. So Comprehend syntax identification allows you to perform fine-grained text analytics. We'll look inside the text, provide the word boundaries, and then start providing labels such as nouns and adjectives which are being used. And you can take all of that information and write better analytics against it. And I want to give you one quick example. So let's take another example where we're looking at customer feedback, voice of customer. And we have a review here of one of my favorites, the Kindle Fire HD8. And you can see from Phil's review here, 4 stars, not bad, that he loves his yellow Fire tablet. Now, without syntax identification, we can get quite a lot of information. We can see that the sentiment associated with this review is positive. And we know that the entity, the thing that's being talked about, is a Fire tablet. And then we can go ahead and we can start running analytics. What proportion of Kindle Fire reviews are positive and negative? Most of them positive, I'm pleased to say. But once we start to add this fine-grained syntax identification, we don't just get the entity. We can start to get more information about that entity. For example, the fact that Phil is talking about the yellow Fire tablet. And so now we can double down and do a double click into that data and not just look at the sentiment of all Kindle Fires together, but start to identify that this is a yellow Kindle Fire or a black Kindle Fire or a punch red Kindle Fire and start to get a sense of what the sentiment is for each of these individual products. So all of this is available today. So right off the bat, you get this broad set of capabilities on AWS. You get a lot of capabilities at the lowest level of driving frameworks, neural networks, and deep learning. You have a set of services which allow you to remove the undifferentiated heavy lifting of building custom models, and this set of building blocks that you can use to compose remarkably sophisticated intelligent systems with our AI services. And whilst I've introduced 4 new capabilities here today, AWS has actually shipped more than 100 new services and major features in the machine learning space since reInvent in 2007. That's more than twice any other vendor out there. So I know what you're saying. How do I get started? And there's a lot of ways to get started. I highly recommend you check out Comprehend. I'm sure you all have text and email and tweets that you want to be able to analyze. But if you want to get a little bit deeper and start working on custom models, we actually wanted a way to put machine learning literally into the hands of our developers. And so we built a physical device, which we call AWS Deep Lens, which is the world's first deep learning-enabled video camera for developers. And the idea here is that you can build robust computer vision models as a way to learn about how neural networks work, how to use SageMaker, build and train them in the cloud, click a couple of buttons, and have them deployed down onto the device where you can run them in real time. Now, we have some Deep Lens workshops right here happening today at the summit, and I highly recommend that you check it out. But right now, I'd like to wrap up and introduce a customer that has been on this journey with us. It's my great pleasure to introduce 21st Century Fox. Thanks a lot.
Cue the music.
Ladies and gentlemen, now please welcome CTO 21st Century Fox, Paul Cheesebro.
Hi, everyone. Thank you to Werner and to Matt for the kind invite to come along to talk to you today. At 21st Century Fox, we're a creative business at heart, providing platforms to storytellers across the world to reach consumers in rapidly new and changing ways. The wonderful showreel was a small example of our creative output, and I hope there's some TV shows and movies that you can recognize and love within that. But technology is core to what we do. Whether that's the camera and the systems that we use to produce events like the FIFA World Cup more recently, or The Simpsons, Deadpool, X-Men and Avatar, or the platforms that we use to power and instrument our content when we deliver it both directly and indirectly to consumers across the world. Technology has always been strategic to us. We have a deeply strategic relationship with the team here at AWS and have had for many, many years. But the relationship is moving up a gear, and we'd love to share a little bit about the journey that we've been on and a bit about where we're going. To date, we've spent a lot of our time and effort on replatforming the enterprise and lifting it into the cloud, embracing modern software-as-a-service platforms, consumer-grade user experiences, and digitally capable infrastructure. This sounds simple, but many of you in the audience know how much heavy lifting this involves and how much cultural change is required within your technology organizations to make this successful. So during this journey, we've consolidated 74 of our own data centers, 74, down to just 4. In effect, our primary compute and storage capability now sits with AWS, and by the end of this year, we'll have 80% of our compute and infrastructure footprint residing in the cloud. With the evolution of platforms like S3 and Glacier, we've also lifted the majority of our content storage and TV and movie archives into AWS. And we now run with more than 25 petabytes of data, basically all of our content at its highest fidelity and truest glory in this environment. This allows us to do some pretty remarkable things and makes us a lot more agile, flexible, and progressive than we've ever been before. And we've really empowered our engineers to drive this revolution. And they've embraced all aspects of AWS along the way, using over 100 of AWS's core services across all of our operations. By doing these things, it's also important to note that we've radically improved our security posture and saved around 25% of our overall technology spend to put it back into the things that really matter to us, and that's the content on the screen. Having spent the time replatforming the enterprise, we've started to gain massive benefits, not just in those cost savings that I mentioned, but also re-architecting the way our creative, commercial, and technology teams all work together. We've used the strong technology underpinnings of AWS to truly help us re-architect the way that we work. Let's use our content supply chain as an example. As we create TV shows and movies, historically, this has been a logistically heavy process where we ship tapes and film around the world and digitize them many times over to produce the final content for our consumers and our partners. Frankly, it's a nightmare of complexity and inefficiency. We've lifted all of these processes and practices now into AWS, where anything shot on a camera is then stored and processed throughout its life using AWS services. And over time, these services have gotten even smarter, where we can use cutting-edge services like AWS's Recognition to automatically analyze each frame of the video to help with view, approval, discovery, and even new product features for our consumers. And here are some of the stats, but I think the best way to bring this to life is to tell you a little story. When Apple came to us last year and told us that they were launching their 4K UHD Apple TV product, they wanted to launch the hardware with a full catalog of 4K UHD content to go with it. And in true Apple style, they gave us 10 days' notice of the product announcement. Historically, meeting this demand would simply not have been possible. But given that we store all of our content in its highest fidelity inside AWS, we're able to transcode, prep, and digitally deliver all of our content to them well ahead of that product announcement, something that just would be unfathomable just a few years ago. And this is really just the beginning. Our creative teams are working very closely with our engineering teams on truly discovering the art of the possible. Now that we run the company on top of such an advanced, ever-evolving platform, we're able to fire up new consumer products and services at a pace and a scale that we've never seen before. Let's take Hotstar, our Indian streaming service, which streams live sports and entertainment shows to an Indian population that is adopting and embracing mobile services at a faster rate than anybody else in the world. The accessible streaming market in India has recently surpassed that of the United States, which very few people know. Hotstar will often stream well above 1 billion minutes of video per day. And during the IPL cricket recently, they broke the world record of concurrent video streams by hitting over 10 million concurrent consumers at the same time. The engineering that went into this feat was considerable and simply would not have been possible without our amazing engineering team in India, but also the AWS Elastic Compute services that we use as a cornerstone for this particular product. And closer to home, we've just completed our coverage of the FIFA World Cup here in the US. And consumers embraced the streaming service like never before. The engineering challenges were slightly different for the World Cup. Every stream was authenticated, and due to the time of the games, we were delivering very, very high-quality streams to desktops and TVs, as well as to mobile devices. Again, AWS helped us both innovate with experience, but really powered a high-quality experience for our consumers at a very, very significant scale. And finally, we've really worked extensively with AWS to underpin everything I've talked about today with a very, very forward-leaning data architecture. Using key components like Redshift and SageMaker, we've managed to move to a much more real-time architecture, and we've done this at a global level across all of our companies, something that would only truly been possible using leading-edge cloud technologies. And it's important to say that we're operating in an industry that really just used to look at weekly or monthly data. So this is a step change in our capabilities. You could say we've moved from looking into the rearview mirror to being able to look forward and around corners. It really is amazing to see what we've started to leverage using these platforms. With AWS, we're obsessive about what we collect and how we store and process it. We're obsessive about how we instrument and provide access to the data, and we're obsessive about the internal and external products that we build using this data. And we're plugged into this fire hose of innovation, where new services can be applied at the flick of the switch or the click of a mouse. We're using this data to get smarter about how we place ads in a way that they'll be seen, but also in a way where they won't break the user experience. We're using this data to truly personalize the features and the functions that we provide to our consumers in our products. And we're using this data in our creative processes to think very differently about how we produce and market our TV shows and movies. And for sure, this is just the beginning. Thank you ever so much for listening. I hope you enjoyed our story.
Thank you, Paul. And also thank Chris. I mean, both of them are amazing stories. Yeah, one of them of something built completely from scratch to really serve modern game play. And the other one, a digital transformation story. And if I look at both Chris's story as well as that from Paul, and also where Matt was talking about, it is all about the data. Yeah, one thing that cloud has done has made IT completely egalitarian, meaning that you all have access to exactly the same compute, the same storage, the same databases, the same analytics tools. So what differentiates companies then is the data that they have and how smart they are in using the data. And so, of course, for us, it's really very important to give you choice in how to actually store your data and how to manage it and how to manipulate it and how to create insights from it. Core, of course, in many applications is still the world of databases. And so stories like those from 20th Century Fox, as Paul told them, really have to migrate significant amounts of data out of the databases that they were running on-premise into the cloud. And of course, we're helping you with that with our database migration service. Since 2 years ago, since we launched the service, we've migrated well over 80,000 unique relational databases from on-premise into the cloud. And the capabilities are pretty powerful. Yeah, you can do automatic schema conversion. It's not necessarily that you move from one database to exactly the other database in the cloud. No, you can actually do transformations from, let's say, an enterprise relational database into an open source database, if that's what you're interested in. And also, it can make use of real-time data replication, meaning that you can real-time replicate data out of your databases on-premise into the cloud, so that your applications don't have to take any downtime when you're migrating your applications yourself. One thing is that customers asked for, when they were migrating out of their, let's say, enterprise-grade databases that they were running on-premise, to actually move over to a database with a different licensing model. And so many of our customers have been asking us for, a rock-solid relational database that actually really can exploit all the cloud capabilities. So that's why we built Amazon Aurora. Been working on that by the launch probably 3 to 4 years, by really thinking about what would be a cloud-native database look like. Yeah, and basically ripping out all the guts and the backend of MySQL and Postgres and replacing it with a truly modern database architecture, meaning that we can easily replicate over multiple availability zones, at least 3, so 2 copies in each availability zone at minimum, meaning that you get 6x replication out of it. And of course, it comes with a different licensing scheme than most of the enterprise-grade databases on-premise will give you. Basically, at a 10th of the cost of those databases. It's highly available and durable, as I mentioned. So many of our customers are running Aurora. It's the fastest growing service that we've built in AWS. And there's very exciting stories to be told. Expedia, which runs, I think, about 150 different travel websites now, is basically powered in the backend by Aurora. It has well over 1 billion rows, does 4,000 writes a second, 25,000 reads a second. And Aurora won't even blink an eye to be able to actually support that kind of performance. Our customers are very vocal when it comes to Aurora. There's a long list of features that they would like to see added, because now suddenly there is a database that is no longer dependent on mid-90s technology. It's a really, truly modern database architecture. So there's a long list of features that we've launched in the past 6 months, and let me go through a few of those. One of the features that we've launched was Backtrack, which gives you the ability to roll back your cluster within seconds to a previous point in your transaction space. On one hand, the use case for that is, of course, that if there's a user error or another mistake that you've made or a software error, that you can actually roll back your cluster. But it's very useful for dev and test. The ability to basically roll back and start again, run through the same set of applications, the same set of updates, and see what happens is an important feature. Something that customers have been asking for is in the original model of databases, you run with a single master. But adding multi-master to Aurora meant that you can get much better latency and much better performance out of your databases because you no longer need to track the single master. You don't need to send your updates to the single master. And most importantly, there is no failover time anymore when the master would fail. So we added multi-master. Basically means that you can run multiple masters in each availability zone, at least 3. And it gives you local write performance. To be honest, this is really the first relational database that really has truly multi-master scale-out over multiple data centers. There is no other database available that will give you these capabilities. Even Oracle RAC requires you, although it has multi-master, to be able to put all the different components in the single room, in a single data center, with a shared disk and shared network infrastructure. Aurora truly exploits all the capabilities that cloud gives you in terms of availability and reliability. Another thing customers have been asking for is the ability to help them with their predictable or unpredictable workloads. If you imagine that the core part of cloud is that we've taken care of many of the hard work you have to do around services. If you think about SQS or SNS or DynamoDB, you never think about instances or servers. The service just works. And so customers are asking us whether we could start adding capabilities to Aurora that will give them the same serverless features that you can find in many of the other services that we've built. So we launched Amazon Aurora Serverless with the ability for you to just set your min and max number of nodes that you want your database to have. And Aurora will automatically scale up and down the capacity of the database. And so really important in all of this is the story of serverless. The ability to not have to worry about sort of the DBA tasks that you used to do when you had to run your own database. And it's probably nowhere more important or nowhere more visible than in DynamoDB. When we built DynamoDB from the beginning, we're really asking ourselves, what would be the best management interface to this? And if you were looking at other database systems, and you look at all the configuration that needed to happen there, there's only one reason for that configuration to take place. The number of connections, the size of your caches, things like that. All with one task, namely to get predictable performance out of the database. So when we built DynamoDB, we just decided to give you that interface. Just the interface to say, this is the predictable performance I want, without that you have to manage servers and nodes and connections and things like that. And so when we're adding backup and restore to DynamoDB, we made the same decision. Instead of you having to do backup and restore, it's basically one push of a button that you click once, and we will automatically backup DynamoDB, and you can do point-in-time restore if that's what you want to do. So that's the world of databases. It's still the core backend of many of our applications. Another area where data plays an important role, of course, is in analytics. And definitely combined with sort of these massive data stores that sort of Chris and Paul and Matt all talked about, S3 plays a very crucial role in that. It is absolutely the most popular choice to build data lakes. If you look at all the security and compliance and security tools that we give you around S3, the ability to run Macy, the ability to, for example, do cross-region replication into different accounts. And so that's all these capabilities that S3 comes with that makes it the ideal choice for building data lakes. One part, of course, is all the different tools that we give you to get your data into the data lake, if you already have that. And there's a whole set of different kind of capabilities that are necessary for you. So one of them is, for example, S3 transfer acceleration, where you can make use of our content delivery network, CloudFront, to actually accelerate moving data from on-premise into the cloud. But of course, we still have the speed of light to deal with. So if you need to move very large amounts of data into the cloud, or if this data sits in a location where it's not easily brought into the cloud, we need to give you the tools. And Snowball, the whole Snowball family, actually helps you with bringing data from your own environment, wherever that environment might be, into the cloud. And so last year, we launched AWS Snowball Edge with a capability for you to actually also run local compute on the Snowball devices because it has AWS Greengrass integrated into it. That means you can write your own Lambda functions and run them there on the Snowball Edge device. And it's very interesting customers. So, for example, the Oregon State University Marine Ships stores the data that they collect from their experiments. Rio Tinto is a large Australian mining company that runs massive automated machinery trucks in their dangerous mines and actually collect data from that. And Boeing's In situ commercial drones also collect data from very remote locations. So for all of those, it's important to actually be able to collect that data locally, maybe do some pre-processing on it using these Lambda functions, and then send the devices back to AWS. However, what we've heard from our customers is that while it's interesting to write your own Lambda functions, it was very important for them to also be able to run commercial software on the device. And so with that, I'm happy to announce today Amazon EC2 on Snowball Edge, which means that you can run your local EC2 instances on the Edge device itself. Yeah, so this is a new instance type family called SBE1, instance type for Snowball Edge. These instances can have a single CPU with a gig of memory, or all the way up to 24 vCPUs with 32 gig of memory. And so it's all designed for pre-processing of data. Yeah, and whether that is compressing, or whether that is machine learning on the device itself, or any type of data collection application that you would want to run on the device itself. Now, S3, in my eyes, has always been sort of the ninth world wonder. The kind of things that we've built in S3 and over time has been amazing. Whether we talk about sort of the ways to ingest, the ways to pre-process, the way to have policy mechanisms that automatically sort of move data around. And important for many of our customers has also been, of course, always the performance of S3. And we've been working continuously to improve the S3 performance year after year. Now, there's one particular challenge that many of our customers had, and that is if you want to run, for example, large EMR jobs, you really have to manage the prefix naming in a single bucket such that you can get the right performance out of S3. So we've been relentlessly working over the past couple of years to increase S3 performance in this way. Yeah? And so 6 months ago, if you were writing a 5 terabyte set of data with 2 megabyte objects, this would have been your performance. But all the improvements that we've made, continuous improvements that we made over the past years, definitely showed up in the new performance improvements that you will see if you've been using S3. Because this is the new performance. Yeah? Instead of, with now, you can have 3,500 write requests a second and 5,500 read requests a second on a single prefix in a bucket. Also important is that all the advice that we've been given over time for you to really manage sort of the read and write performance of S3, no longer you have to worry about those. Because you can use multiple prefixes in the same bucket without having to worry about exactly what the naming of those prefixes is. And definitely, this is actually the single request rate, but you can easily parallelize this. Yeah, so if you just fire up 10 prefixes, it is easy for you to actually get 50,000 read requests a second. So really, parallelization of these requests, without that you have to worry about the naming, is a very important improvement, performance improvement for S3. Of course, S3 is not your only data source, especially not if you're operating in the analytics world. Yeah, there's probably you have data stored in many different places. You may have some in S3, maybe your complete data lake sits there, but you may have some relational data in RDS, or maybe some data in DynamoDB, or data still on-premise in one of your databases. And so AWS Glue helps you discover and manage the different data sources that may be living in different silos in your organization, to then be able to bring that data to all the analytics tools that we have for you. And so Amazon Athena is great for sort of this ad hoc data discovery. EMR is really great for unstructured big data processing. Redshift for data warehousing. Kinesis for real-time analytics. Elasticsearch for log analysis, but also great visualization with Kibana and other tools. And of course, QuickSight, if you really want to build dashboards and visualizations in a very simple and easy manner. And of course, also be able then to actually move that data into your machine learning environment, and whether that is actually the output of your analytics process that then goes into machine learning, or whether it's just data that you directly get out of these different data sources into your machine learning environment. So many of our customers that have great success with analytics. And if you take, for example, the Hearst Corporation, they process click streams from more than 300 websites and deliver this to their website editors within minutes. In all of this, we've had a lot of experience by now how we are building our systems, and how our customers are building our systems, and how our customers are being really successful on our platform with building new applications. And so all of this has been collected into what's called the well-architected framework. I really urge you to check out the framework because it gives you important guidance about what are sort of best practices on our cloud environment. And there's 5 different pillars. Operational excellence, security compliance, reliability, performance, and cost. And all of those are centered around a set of hardcore principles that we believe are important in the way that you're building your applications. And each of the different pillars has their own set of what I would call sort of best practices and principles of, for example, security and compliance. Really giving you advice about what is the best way to integrate security into your environment. Because remember, we've been giving you a whole set of new tools to actually really keep control over your environment and the best practices around security. And implement a strong identity foundation all the way over to how to prepare for security events. And so each of those pillars in the well-architected framework will give you advice in a matter of sort of questions to ask. Each of them may have 50 or 60 different questions that you should be able to ask yourself and answer. And actually, I think most of these questions are things that you should be able to do on-premise as well as in the cloud. I do think security is probably one of the most important pillars there. I'm a strong believer that these days, security is no longer the job of a security team, or just a security team. I think security is everybody's job today. If we really want to protect our customers and our business, we all have to take responsibility for security. It's no longer the case that somewhere at the end of your development process, the security team comes in, sprinkles some magic dust over your application, and suddenly it is secure. It is definitely in a world of continuous integration and continuous deployment that you have to have a very different pipeline. Security needs to be deeply integrated into our development processes if we really want to keep our customers and our business secure. And there's many different sides to this. Of course, there's the tools and services that we've built at AWS. There's all the compliance features that we have and that we're delivering for our customers. We have a great security partner network that builds very advanced tools. Many of them you can find back here in the expo hall. And of course, the way that we actually give you a contract around data protection. And so in all of this, I believe there's a significant change happening, especially because of continuous integration and continuous deployment, that we really need to make sure that our pace of innovation needs to meet the pace of protection. And you do that through automation. Now, I know especially if you're younger businesses, this is not something that you immediately start thinking about when you think about sort of building your new applications. But you need to make sure that you actually make use of all the tools that we give you so that you can protect your customers. And we have all these different automation tools available for you. And I'll pick on a few of them. I think they're really important. For example, it starts off with Trusted Advisor. Trusted Advisor will do a sort of, let's say, a static scan of your environment, and will give you advice around security groups, ports that you may have open, sort of the simpler things of security. To be able to track anything that happens in your environment, you need to enable AWS CloudTrail. It logs every access to every object, every operation, and pushes that into S3, encrypts it there, and allows you to then run all sorts of alarming on it using CloudWatch to really make sure that you have a really deep auditing capability, a deep understanding of exactly how your systems are being accessed. Config rules is one of my other favorite applications when it comes to security automation. It basically makes snapshots of your environment and clearly indicates how your environment changes over time. Again, you can put all sorts of alarming on it to make sure that no unauthorized changes are being made. One of those config rules might also be, for example, no EC2 instance should be started without an encrypted disk. And if the instance then does start, the start should fail if the disk is not encrypted. In all of this, encryption plays a crucial role. In my eyes, it is the only tool we have to make sure that we as customers are the only ones who can access our data. So we built encryption into all of the different pieces of AWS. And whether that starts with transferring it over the network or in REST at all the different services, each and every one has encryption integrated into it. And most importantly, of course, is that you can bring your own keys. You can now, of course, ask AWS to generate these keys for you. But if you really want to be sure that you're the only one who decides who has access to your data, you should bring your own keys. And a good example there is, for example, Redshift. In Redshift, each data block is encrypted with a random key by default. And then that set of random keys is encrypted with a master key. Now, you can bring the master key, or you can have us generate the master key for you. But if you bring that key, you can be assured that you are the only one who has access to your data that sits in your data warehouse. With encryption, especially encryption on the network, of course, comes the need for managing certificates. And the AWS Certificate Manager is a great service with that. In my past lives, around managing an e-commerce website, I've had a few cases where my certificates would expire, and I wasn't aware of that. So AWS Certificate Managers not only gives you certificates for free, it also automatically renews your certificates when they expire. In all of this, secrets play an important role. We all have secrets to keep. And whether those are AWS keys, whether those are database passwords, whether those are third-party API keys, all of them are very crucial components of your system that need to be protected. And in the past, we may have put them in the code, or we may have had them in configuration files, but neither of that is, of course, a secure approach. So with Secret Manager, you can now manage all of your secrets in one location, making sure that no one has access to your secrets but you. And an important part of that is actually the automated management of database passwords. We've had one customer that I think ran 50 different MySQL databases and really wanted to do password rotation. But managing 50 databases and the applications that require access to those databases is a difficult task. And so they rotated their passwords only every 6 months. Now with Secret Manager, they can automatically do the rotations of passwords. And so they're doing that now every 6 hours. So you can imagine that greatly enhances the security of their applications. So with all of this, I really want to bring this point home, that security now is all of our responsibilities. It is no longer that as a developer, you can say, it's the security team. No, we all need to take responsibility for security if we really want to have our customers be safe. Now, to talk about their digital transformation using well-architected principles, I'd like to invite on stage Robert Palatnik, the Chief Technology Architect at DTCC. Robert. Thank you.
There you go. Thank you. Good morning. 1,610 trillion. Inside DTCC, we actually say 1.6 quadrillion. But the AWS team told me that's not a real number. So who are we and why do we use such numbers? DTCC was created by the financial markets to solve a paper problem. 50 years ago, if you bought shares in a public company, usually through a stock exchange, you sent a check and you received a paper certificate of your stock shares. So in 1973, DTC was formed by the financial industry to put old stock certificates in a vault and create a computerized central ledger. Today, we clear virtually all trades in US stock and bond markets. About 90 million trade sides a day from over 50 different markets. We also have expanded our financial offerings to other financial products, including global derivative markets. So that 1.6 quadrillion number is the total value of transactions we process annually. DTCC is the Depository Trust and Clearing Corp. So trust is our key middle name. And that is the key word as we are the trusted infrastructure for the financial industry. We are regulated by almost every global financial market in every global market we operate, by every financial industry regulator in every global market where we operate. They supervise our activities from business models to systems resiliency. And they're very interested in our infrastructure. And our infrastructure now includes AWS Cloud. So I'd like to take you on our journey of cloud enlightenment, how we moved from a very controls-oriented mainframe technology culture focused on security, resiliency, and privacy. We even have a COBOL fan club. And we moved ourselves to the cloud. It all started with an opportunity. Let's go back to 2012. We are emerging from the Great Recession caused by the credit crisis of 2008. The financial industry is focused on cost reduction, and the regulators are focused on creating laws to address the root causes of the credit crisis. In particular, they're focused on bringing transparency to trading, in particular, the more complex financial transactions called derivatives. This was different than anything DTCC had looked at before. We were asked to create a trade warehouse of derivatives transactions to help the industry meet a regulatory agency, the CFTC's requirements. It had to be free. It had to provide pricing data. It had to be real time. It had to be public, meaning no logins, no capture of user details. DTCC runs a private network connected to the financial industry with our own data centers. We have no model for public access. Did I mention we're highly regulated? So the build estimate for internal infrastructure was over $4 million for a free service. Our business was not happy. Our hardware vendors were very excited. A couple of our more innovative team members decided to try out a cloud model literally over a weekend in early March 2012. And by Monday, they demonstrated a simple working prototype on AWS by taking snapshots of ticker data, dropping it into S3, and making it available as an RSS feed. It was public data, so our security and compliance teams got quickly on board. We were actually in production in December of 2012. The original estimate internally was $4 million for infrastructure. The first year, we spent less than 1% of that on AWS costs. 5 years later, we have 3 times the daily volume, almost 20 times the data stored, and our costs are 1/3 of the first year. And there's no hardware refresh cycle. We actually sent a team to AWS reInvent in Las Vegas in 2012 to get educated, and they came back super energized, looking for more opportunities to leverage the cloud. So we partnered with AWS as a first opportunity to make their Glacier service compliant with a regulatory rule that requires immutable storage, and we immediately realized benefits. We were able to move a tape archive to Glacier and reduce our costs by 90%. We reduced our costs from $2.5 million of maintaining tapes and tape silos to $250,000 per year. We don't have infrastructure refresh needs. We meet regulatory compliance for archiving our data, and we enhanced our data searchability over being able to search through tapes. So now we're moving data into the cloud, but can we actually do something with that data? Our regulators and the financial industry are constantly asking us to gain better insight into that data. We collect transactional data from all the different markets. Can we actually do something with that? So working with AWS, we've been building out a cloud data analytics platform, and we've also been building internal data science skills. We started with a risk data platform, which does an analytic process once a month on data collected all month long. So an immediate benefit was paying only for resources we needed once a month at the end of that month. Next, we provided our clients with a risk calculator so they can run their own risk scenarios. And we're now moving our data into a warehouse on AWS using Snowball, and we're going to implement the data lake to create data marts on demand using EMR, Presto, Redshift, and Postgres. This is a picture of our new user experience. We've given this client calculator out to our clients. For those of you who know DTCC for a long time, you'll probably be most impressed that we've left our long love affair with 3270 green screens. This is a number of the AWS services that we're using to support what I've just shown you. And literally, the number of AWS services that we're taking in and absorbing into the culture is changing on a monthly basis. So our story so far is this progression of maturity on data. In 2016, the financial industry challenged DTCC to help reduce complexity in processing exceptions. We process over 100 million transactions a day, so even a small percentage of exceptions literally means 10,000 trades must be manually corrected to make sure they can be processed and settled correctly. So we worked with our clients, we built a common workflow for processing exceptions, and we standardized the data model with the expectation that in the future we'll be able to use machine learning principles to be able to identify exceptions in advance and find resolutions. The business goal was a working pilot within a year. We decided to go all in on AWS, using serverless and platform as a service, Lambda, Aurora. So for transaction processing, we had many engineering challenges: the right balance of performance and capacity versus costs, resiliency, coordinating between multiple data centers in different regions of the US with multiple AWS regions. We needed to integrate the client experience, which was built by a third party, pushing the envelope on all angles for DTCC. Large projects in the financial industry normally take years, and then adding the client migration to those and the client adoption and changing their processes and systems adds additional years. With AWS, we deployed the system to pilot production in 9 months. The new system is a single pane of glass to manage exception processing. We've already built significant industry momentum. I want to mention resiliency and emphasize how important it is for DTCC. The financial markets expect DTCC to be there without fail every single day. Our regulations have requirements for out-of-region recovery, minimal distance to another region, recovery time objectives, recovery point objectives, testing schedules. Our regulators visit our facilities and they review our disaster recovery tests. AWS provides multiple services and multiple options for multi-region resiliency. They are well beyond what we could do on-prem, but they're very different from on-prem. So it's our responsibility to design and engineer those services to support those requirements. We spend a lot of time engineering resilience model, and we're constantly conducting recovery tests on different disaster scenarios. Our regulators require regular re-verification of our DR capabilities. We're good at shutting down a DTC's data center to prove a test, it's a little bit of creative science to simulate that in AWS. So we are working closely with AWS on what that could look like. So that's our journey to date, starting with an opportunity to see the cost and benefit scales of the cloud, moving to the Lego toolbox of AWS data capabilities to build our own data science, advance our own data science capabilities, and moving to the first implementation of AWS Cloud, of transaction processing in AWS Cloud. So what's next? We're very focused on resiliency and improving automation. We've created a chaos team based on best practices adopted by Netflix and others. We're partnering with AWS on the best models that will make our regulators comfortable with continuing to progress in the cloud and moving eventually along a roadmap to take mainframe applications and critical transaction processing applications and move them to AWS. Oh yeah, and we're also building our first blockchain system with the industry on AWS. So why are we here, and why is it we're telling you this story without any fancy videos? We believe that communities are stronger than individuals, and the more enterprises and the more of you that move to AWS, the stronger AWS will become and the more resilient that cloud will become, which is going to be a win for all of us. Thank you very much.
Thank you, Robert. It's always very humbling to see how many of our services, the large collection of services that we build for our customers, really help driving digital transformation in a very traditional business, like DTCC. Now, of course, there's one last topic to look at. I mean, we've talked about machine learning, we talked about databases, we talked about data lake and analytics, and how well architected and security. Compute, of course, still plays a very important role. Yeah, and so, as always, we want to make sure that you have the right tools to do your job. And of course, compute has been changing over time, where we started off with virtual machines, then the rise of containers, and then the rise of serverless. For many of our customers, however, they're always using a combination of these different compute services for them. They may run some prepackaged software in a VM. They may have broken up their monolithic application into container pieces, and they may be dropping serverless everywhere to connect the different AWS services. So if I look at virtual machines, they still are the core of most of our customers' applications. Yeah, although, as much as containers and serverless are on the rise, virtual machines still is sort of the bread and butter of compute. And if I look how applications are running there, some of them may even be running for months or years. I recently got a tweet from one of our customers saying that his virtual machine had just had its 10th anniversary. So it is clear that if you then run software in that virtual machine, you don't reboot it, or you don't actually restart it with new software. You really patch the software that is running inside the virtual machine. And it's great, actually, for really running existing software. Yeah, and it's part of a very large footprint. And as always, we always wanted to make sure that you would have the right tools for your job. And as you can see, whether you want to have, whether you're memory optimized, or whether you are compute optimized, or storage, or big data, we really want to make sure that you have the absolute best virtual machine available for you to do your job. And one of the things that I'm most proud of here is those numbers behind each of the instance types. Yeah? The M5 means it's already on the 5th generation. And I don't know if you've ever been part of these hardware refresh cycles that we used to go through in our data centers. And that also always caused great pain if your machines were coming off lease and you had to replace them with other ones. In the cloud, these things come for free. We're automatically updating our virtual machines to sort of the next generation of it. And if I look at sort of one of the very popular ones, yeah, the R4s, for example, that are really good for running high-performance databases, in-memory caches, big data analytics, all those memory-intensive applications that you're running on EC2. Today, I'm happy to pre-announce the R5s. Yeah? It goes from a Broadwell processor to a Skylake one. It clearly increases the maximum amount of memory that you can have, as well as the maximum number of virtual CPUs. And we also comes with an R5D type, which basically gives you the capabilities of running a 3.6 terabyte non-virtual memory, non-volatile memory storage included. So for these applications, they're running in the R5s are the ones that actually can make use of significant parallel processing. Yeah, so we really can make use of all the cores that sit in the machine. However, our customers also asked us for a different approach to memory-intensive applications, especially those that are using, for example, electronic design automation. Yeah? Especially those applications that have a very high licensing cost per CPU, per core. And so we are now into pre-announcing as well the Z1D instance, which gives you probably the fastest processor that is available in the public cloud. Yeah? The goal really here is that you get a very high sustained turbo CPU clock speed of up to 4 gigahertz. Yeah, and the CD1s have 48 virtual CPUs and a massive amount of RAM. And it's really well suited for these electronic design automation workloads, certain relational database workloads where you have to pay high licensing cost on a per core, and other HPC workloads. So with this, we've really been extending based on your feedback. Because remember, that is the most important part in our relationship. You continue to give us feedback about what kind of, not only virtual machine, but what kind of services you'd like to see. And so this continuous feedback cycle is really important to us. So the R5s and the Z1Ds instance families will be available in the coming weeks. Another challenge that quite a few of our customers talked about has to do around the IP address space. And so yeah, your IP address is not always just a number, not just a routing capability. Quite a few of our customers, for example, those with commercial email services like SparkPost and SendGrid, actually rely on their IP address reputation. So if you then want to move from on-premise into the cloud, you basically get assigned a new set of IP addresses. So we really wanted to make sure that if you would have to change your IP addresses, which comes then with sort of a reputation loss, that we need to find a solution that for customers that really would like to bring their own IP addresses into the cloud. So this is a new feature for Amazon VPC, to be able to bring your own IP addresses. And also what we'll do for you is actually advertise those IP addresses for you so that you no longer have to manage those things on-premise. If we then look at sort of the evolution of compute, containers clearly start playing an increasingly important role for many of our customers. And I think there's a particular reason for it. Remember that all the way at the beginning, I was talking about sort of these massive monolithic applications. And the challenges with these monolithic applications is that you have to scale them at the scaling requirement, often of the smallest component in there. I remember that in Amazon, the retailer, at one moment, we had our customer master service, basically the code that operated on all customer data. And one part of that was a component that basically did what was called a recognized customer, basically a login service. And in that same piece of monolithic software also set the address book service. And so these two things have very different scaling requirements. The login service basically needed to be scaled at every web page. The address book service, you only need to scale whenever you check out a product. And so by having to force this monolith to scale, we were wasting enormous compute resources. And that's a pattern that I see coming back over and over again, where containers are now being used to sort of decompose these massive monoliths, and where each of the different container blocks have their own unique scaling and reliability and security requirements. Because security is an important part here as well. Because in this monolith, this customer master service that we were running, basically the address book service had access to the credential store. And the login service had access to the address book store. Clearly a violating of separation of concerns. And so the ability then to move to the container world and have each of your containers have their own unique identity and access controls is an important feature for security. If you think about updating containers, you don't do that anymore by patching. You basically make them immutable and just do the next version at your launch. With the Elastic Container Service that we built, we really wanted to build the absolute best platform for managing containers. And especially when it comes to the deep integration with all of the AWS services. Yeah, the ability to have all your containers of the same type, to be able to have that end up in CloudWatch logs in the right place so that you can look at all the different container instances that you're running. Or deep integration into the security capabilities. Or the ability to have the application load balancer to actually directly fire up your container tasks. And so many of our customers have been building with containers already for quite some time. Yeah, and so it has, ECS has well over 100,000 active clusters with hundreds of millions of containers starting each week. It represents really a 400% year-over-year active customer growth since 2016. But according to a recent survey, about 63% of responders run containers on web services, run containers on AWS. And many of those actually are running Kubernetes. And so the one thing that customers have asked us, please run Kubernetes for us. Yeah, because running your whole container management system yourself sort of brings you back in the pre-cloud era. So we launched at reInvent EKS, the platform for enterprises to run production-grade Kubernetes environments. Yeah, and it actually really is a close relationship with the open source community to really make sure that AWS is the absolute best place to run your Kubernetes clusters. One thing, though, is that there's still a part of that whole container environment that is still tricky. Namely, you have to manage the infrastructure underneath them. These containers still map down on virtual machines. And so to take that heavy lifting away from you, we launched AWS Fargate, which makes that you no longer have to manage the infrastructure for your container clusters. And so AWS is the absolute best place to run your containers. And whether you use ECS or Fargate with ECS or EKS or soon AWS Fargate for EKS, this is the absolute best place to run your containers. The last pillar, of course, is that of serverless. And there is really a true revolution going on in the world of building applications. And because we no longer want to actually write and manage all these different compute infrastructure pieces, we just want to write business logic. And as you remember, that first slide I showed you from iRobot definitely is an indication of that. And so many different pieces within AWS are serverless from day one. It's just that compute was the only piece that was still missing. And AWS Lambda clearly gives you now those capabilities to no longer have to worry about any of the compute infrastructure that you need. You just write your code, and AWS takes care of automatically scaling it up and replicating it over multiple availability zones. I remember this was that iRobot slide, and as you can see, there are no servers in this at all. And it's very important for the people at iRobot, because even though you buy your robot or you buy your Roomba, you don't pay for this service. So for them, it is extremely important to manage their cost. And so one of the very important concepts around serverless application is that you not have to pay for idle capacity. If you would have to run a whole cluster of EC2 instances, even whether you're running code in there or not, you have to pay for those. In the case of AWS Lambda, the only thing you have to do is actually just write your code, drop it in Lambda, and make sure that we will scale up and down. And you only have to pay for really the execution times of your applications. One thing that really surprised me around serverless was that often when you have new technologies, it's sort of the young companies that are really jumping on board first. But what we've seen is that actually quite a few of our enterprise customers immediately starting adopting serverless, because it actually really reduced their infrastructure management tasks, and they only had to pay for the execution as it was happening. And as you can see, these enterprises are all adopting serverless immediately. So in the whole compute world, we still want to make sure that you get exactly those tools that you need to do your job. And whether those are all the different virtual machines types that we have, whether it is the different choices of container systems, or making use of serverless to no longer have to manage your infrastructure at all. The important part here is that you have choice to build exactly your applications in the way that you want to build them. And so with that, I'd like to thank you for being here in the keynote this morning. I urge you to check out the AWS user group, especially those here in the Northeast. They have a booth out in the community area. So with all of that, go build. Thank you.